Welcome back. In this lesson, we're going to take a look at something called central tendency. Now, you might be more familiar with terms like average, mean, median, or mode. Central tendency is actually the word that we use to describe them all, because every time someone tries to describe the three of those other things, mean, median, mode, put together, they tend to use one of those words. They tend to say things like, well, the mean is the average. Well, technically, that is true. They say the median is kind of the middle of the data. Well, actually, that is true too. Um, but it's hard to find a nice word that represents all three of those things together, so we call them all central tendency. It's what number we're looking at as a typical central value. So the one that you're probably most familiar with is the mean or mathematical average, sometimes called the arithmetic. Geez, I can't talk today. Anyway, it's the math average. And it's pretty simple. All you do is take all of the data points that you want, whatever values they are, add them up, and divide by the total number of data points. Um, so I need to point out again that this is only going to work if you have interval data. Obviously, doesn't work if you have nominal data. So you can't, for instance, take the average of three people with brown hair, two people with blonde hair, and one redhead, and say the average is this color. It doesn't really make sense unless you're in art class and playing with paint, and that's completely different. But anyway, for our purposes, we're only going to use numbers or numerical data. And again, the biggest part of this lesson, I think, for most people is just going to be getting used to the new notation. So you'll see that there's a little equation down here. And by little equation, I mean fairly small. It's three parts. And you just need to get used to what the variables are. So on the left-hand side, we call that variable x bar. It's x with a line over top of it called x bar, and it represents the mean or the mathematical average. On the right-hand side, I'm going to start with the bottom because it's easier. N is going to be our number of data points. And on the top, x's are our individual data points. Sometimes we'd call them, x1 and x2 and x3, but we're going to call all of them cumulatively x's. And that symbol in front of it is actually the Greek letter sigma. To be specific, it's a capital Greek letter sigma, and it represents sum of all, or basically just add them all together. It's an operation, just like square root or anything else. It tells you to add up all the x values. You may be familiar with that one if you've ever used Excel. It's actually the symbol button you use to add up a whole bunch of cells. And in mathematics, that's what it means, is sum of all. And we're going to come back to that later in the course and look at it in a little bit more detail with summations. But for now, we're just going to use kind of the baby version of it, which is just that symbol means add up all the numbers that we have. Okay, so if you've got that notation down, then it's actually pretty straightforward. If you want to find the mean of a data set, add up all the numbers, divide by the number of data points. So our first example, we've got a fairly short data set there, 6, 4, 10, 7, and 3. So if we want to find the average or the mean, we just add up those values, 6 plus 4 plus 10 plus 7 plus 3. And we divide by the number of data points, and there are 1, 2, 3, 4, 5 of them. And when we do that, we get 6, 10, 20, 30 over 5, which means the mean is 6. Pretty straightforward, pretty easy to do. The median is arguably even easier. The median is the central number of our data points. So we take all of our numbers, we put them in a row, and we say, what is the middle number? Now, I'm going to go to example 2 and just explain this. We have the numbers, again, that's the same data set we had actually in the last example, 6, 4, 10, 7, and 3. And I've had some students say, okay, so the median is 10. It's the middle number. Here's the one little trick that you have to worry about. Um, you have to do the middle number when they're actually in order, because in this case, 10 is not the median. 10 is the largest possible value you could get. So it does not represent the central tendency at all. So I'm just going to rearrange those and put them in order from smallest to largest. So 3, 4, 6, 7, and 10. And then I look at it and say I've got 5 numbers. The third number is the middle one. And so the median And unlike the mean, we don't really have a symbol to use for median, so we're just going to write out median equals 6. Okay, I do want to point something out now just to kind of get you used to it because we're going to have to use this in the next lesson. The middle data point of 5 data points is the third one. And a lot of people want to think that the middle of 5 is 2.5, which is sort of true if we're thinking half of 5 is 2.5. However, when we think of half of 5 is 2.5, 2.5 is halfway between 0 and 5. But we're not going between the 0th number and the 5th. We're going between the first number and the 5th. So we're always going to have that kind of round up to the next half. So the halfway point of 5 numbers is not 2.5, but the third number. Similarly, in our second data set, we have 6 numbers. You would think that the middle number would be the third, but that would mean that there's only 2 to the left and 3 to the right. We actually want the 3.5 number. I know what you're thinking. How do we find the 3.5 number? Well, the first thing we do is actually put these in order, as we should. 3, 4, 6, 7, 9, and 10. This looks a lot like our last data set, except that we added one more number to it. Okay, so now I've got 6 numbers there, and the middle point is actually going to be kind of halfway down there. It's not an actual value because we have an even number of values, so we can split the number of values in half, but there is no central value. And what we do in this case is we just get close enough to the center and say, okay, it's got to be halfway between the third and fourth number. So halfway between 6 and 7 is 6.5. And that's it for that. So if there's an odd number of data points, there will be a central one. That's our medium. If there's an even number, it will be between the central 2 numbers. In this case, half of 6 would be 3, so it's going to be halfway between 3 and 4. And finally, the mode. This one's even easier than the median. It's literally look at the data set and ask yourself which of those values appears more frequently than the others. Now, this one can get a little bit tricky as far as how we treat these in reality. Now, for these number sets, they're fairly small, so we're going to take it literal and say it's got to have the most in order to be the mode, or in some cases, it could be tied for the most. In huge data sets, anytime there's a spike between values, even though they may not be exactly the same height or the same frequency, we usually consider them both modes. And it is possible to have no mode or multiple modes. Now, usually if there's a whole lot of modes, they're not modes, they're just average typical numbers. So on our first data set, we have the numbers 2, 5, 6, 9, and 11. Didn't try and trick you this time by putting them out of order. And I see all of them appear once. So in this case, we would just say that this has no mode. We would not say that it has 5 modes, all of which with equal frequencies. That's just kind of ridiculous. Now, the second one, we've got 2 3s of 4, 2 5s, 3 6s, 1 8, and 2 9s. And I think the most frequent value there is a 6. So we write down that the mode equals 6. On the last one, we have a 2, 3 3s, a 5, 3 7s, and a 9. So we'll say that the mode is 3 and 7. I'm just going to put 3, 7. So it's bimodal. It has 2 modes. Very seldom would we have more than 2 modes in a graph. There are possible reasons why it could happen, but in real life, very seldom is there more than 2 modes. I wanted to mention outliers. You probably recall we mentioned an outlier in the last lesson. And an outlier is just a member of a data set. So basically one of the values that is not just like different than the others, but is drastically different enough that it really stands out. That you look at it and go, that's weird. I'm not sure why that's there. Or you've got a suspicion why it's there, but it's there for a weird reason. It doesn't fall in line with the other values. So just as an example, if you have test marks of 75, 80, 75, 0, and 85, um, you're not going to say that 85 is an outlier because it's higher than all the others. It's still in the same ballpark. The 0 is the one that's in a ballpark, or the one that's way off. So that's the one that we would call an outlier. And not all data sets will have outliers, but many of them unfortunately do. Sometimes it's actually incorrect values or things that were recorded incorrectly. So for instance, people's heights collected in inches, but one person put it in centimeters, so it's way, way different than anyone else's, is a good example. I was just looking at an ad on realtor.ca, and there's a house out in New Brunswick that I was looking at. House price out there are way cheap compared to here. So there was a little house, and it wasn't big by any means. It was $70,000. When you think about house prices here, that's super cheap. But the interesting thing was when I looked it up, I'm looking for property. I want it like land. I want to be able to plant a big garden and start farming. So I looked at it, and it listed the land size as 22,300 acres. Just to put that in perspective, a big property in KW is a quarter of an acre. A quarter of an acre. And an acre of land in most KW areas would cost about $1 million. So this was a $70,000 property with a 22,800 acre land. And I'm pretty sure what they meant to put in was 22,800 square feet, which is still a decent sized property. But yeah, that's a big, big difference between a square foot, which is a foot by a foot, and an acre, which is the size of a football field. So there's an example of what would be an outlier if I was looking at the property sizes of a bunch of houses. In this case, I think our 0% is an outlier, likely because the student missed a test. It would be a super outlier if that was actually what they got on the test. Like they wrote the test and attempted it and still got a 0. That would be uncharacteristic given their other grades. So that would be my possible explanation for it. The next one, we have 5 people we selected to look at how much they make per hour. So we get normal values like $11. Well, less normal now that minimum wage is a little bit higher, but $11 an hour, $23 an hour, $14 an hour, $19 an hour, and $1 million an hour. And I would say that the million is an outlier, not because it's the highest, but because it's ridiculously out of whack with the others and makes you suspicious. Now, we'll point out that that represents Mark Zuckerberg, the founder of Facebook, and that is actually pretty close to his real hourly rate. Obviously, he's not an employee who gets paid by the hour, but if you look at how long he's been working on Facebook and how much money he's made in total, it actually works out to about $1 million an hour. I just want to take a moment and think about how rich that is. So just to put this in perspective, I like thinking of this as an example. Let's say he wanted to buy a Lamborghini, and the Lamborghini in Kitchener cost $1 million, but it was on sale in Guelph for only $100,000. That's a pretty good sale, $900,000 off. It's not worth his time to drive to Guelph to get the cheaper car. He's better to just stay here, buy the more expensive car, and collect more money. That's ridiculously rich. But anyway, that's just my little aside for the lesson. Last thing I just want to talk about before I let you go, it's fairly short, is we've got these different methods of central tendency to use. Which one should we use? And the answer is it doesn't, it's hard to define. Like, in this situation, you always use this, and in this situation, you always use that, and so on. Some things that I do want you to keep in mind, though. When you have an outlier in a data set, outliers are going to affect the mean. So just going up to our Mark Zuckerberg example, if I take those numbers, the mean, add up those 5 numbers and divide by 5, I'm going to get a number just over a million divided by 5, which is just over $200,000 an hour. That to me doesn't represent central tendency of a group. If I took the median of that data set, there's 5 numbers, and the middle one would be $19 an hour. I think that's a much better representation of standard central pay for most people, or hourly wage for most people, given that data set. So if we have outliers, then it's often a good idea, if we can, to use medians because they get rid of the outliers. And by the way, for marks in classes, teachers prefer medians to averages. They usually call it averages or talk about averages, but they're really looking at medians, because they want to know kind of where the average. This is where I hate this. You always want to use the other words to mean the same thing. You want to look at where the central students are mark-wise. So for instance, in one of my classes last semester, my median was about 60-ish. My average was about 40-ish. And that's because I had about 5 students in a small class that weren't actually participating or handing in any of the assignments. So the ones that were doing well. They were getting marks in the 60s, 70s, 80s, and those who weren't were getting zeros. And unfortunately, the zeros made up almost a third of the class. So because of that, they would have drastically, well, they did drastically drag down the average, but they don't really change the median that much. It just shifts the median over 2 people. Um, and they were likely going to be at the bottom of the class even if they did participate. So they probably didn't change the median at all. So if you've got an outlier, consider using the median instead of the mean. If your data is roughly symmetric, meaning that it's kind of looks normal, there's nothing too unusual about it, um, the mean and median should be almost the same values. So it doesn't matter which one you use, whichever one you think is more appropriate. I will say that the one time that you may want to use the mean is when you want to represent a number, but you want to also convey kind of an overall amount. So for instance, if I said I make an average of $500 a week, um, an average of $500 a week lets people know that I probably make $13,000 a year. Um, wait, that's, yeah, 52, no, 26,000. Jeez, what am I thinking? Um, if I know I make 500 a week, I know I'm probably making around 26,000 a year. So sometimes you can convey extra information by giving a mean. Whereas if I just said my median pay is $500 a week, um, I could have a couple, I could do like 500, $550 weeks, but then not work a third of the year. And it would still have a median of about 500. Likewise, I could have pretty much a paycheck every week for $500, but then get like a $10,000 bonus 5 times a year. And that wouldn't change the median at all. So sometimes the mean is a little bit nicer for that. And when it comes right down to it, the mode in almost all situations is completely useless unless you're just looking for where the peaks are and why they're there. Um, but they do come in handy if you're dealing with non-numeric data. So for instance, I might want to know what the modal hair color is. Um, well, I probably wouldn't because I'm a math teacher. Actually, no, that's probably a reason I would, because I like weird statistical stuff. But in general, it probably doesn't matter. But if you're a hairstylist and you're looking at which hair colorings and stuff to get in, you probably are interested in the mode. What is the most common color required? Or for instance, if you're working at a clothing store and you want to stock different clothing, t-shirts as an example, the modal size is probably important to you. Knowing that more people will buy a medium shirt than any other size is useful data. Whereas finding the average shirt size, first of all, if you're going with small, medium, large, extra large, there's no such thing as an average or well, arguably a median, because I suppose the data would be uh, ordinal. It does go in order, so you can say what the middle person would wear, but it's still not very helpful. Usually non-numeric data, you'd want to use the mode. Not many examples of where you'd use a mode with numerical data, except math class. Anyway, I'm going to stop there. Yeah, I guess we'll see you next time. We're going to look at this same topic again. Well, not the exact same topic. We're going to look at this topic again with grouped data. So instead of being given a list of just single numbers, we'll be looking at larger data sets.